For years, science has pushed the boundaries of what was thought to be possible. Innovations such as the light bulb, the engine, airplanes, vaccines, and many more have changed the world with our perceptions of it. What if I told you there's one more on the horizon? CRISPR-Cas9 will usher in a new age of biology and may very well shape our lives in the future. Today, I will enlighten the audience about CRISPR-Cas9 editing and tell you why and how we should be using it today. CRISPR editing has the ability to cure disease, improve viral immunity, and remove defects before a baby is even born. Speaking of birth, let's take a look into the birth of this technology and what exactly it is. Gene editing has been toyed with since the Nazi eugenics program, but was often expensive, not precise, and hard to implement. In 2012, Donna and Emmanuel Carpentier were the first to propose that CRISPR-Cas9, enzymes from bacteria that control microbial immunity, could be used for programmable editing of genomes, as you see in this graphic to the left, which is now considered one of the most significant discoveries in the history of biology. CRISPR-Cas is a comparatively cheap, efficient, and easy-to-use alternative to already existing gene editing tools, according to the BMC Med Ethics. Additionally, after years of research, it has been found to be successful on the human embryo. As you can see, any Joe Schmo can buy a CRISPR-Cas9 editing kit right here for only $286.56. So genetic alteration is now in our wheelhouse, but how might we use it, and is it even ethical? Something of this magnitude is sure to have many risks involved, and the topic of gene engineering has always been under much scrutiny. Many claim that this technology is not worth its risks. Researchers point to previous attempts at gene editing, such as the Nazi eugenics program, which was designed to make the model human race. According to Bruta 224, changes could eventually extend beyond the therapeutic level to be used for enhancement, ultimately giving parents the ability to select, modify, and create exact genetic traits, a made-to-order designer baby. Surely we can all agree that this is no future we should invest in. Life is precious, and this is why we have laws. This technology can be heavily regulated and thus dismiss the possible future in which we are designing children's. Researchers have also highlighted the possibility of a bioweapon such as the supervirus created using this technology. But despite this fear, it is very unlikely and perhaps not as super as one might think. CRISPR-Cas9 may be able to change traits of said virus, but researchers at PGED have highlighted that such modifications would have to take place in a virus already known to man, for example, the flu virus. This being said, we would have all the necessary knowledge of the virus in order to combat it and immediately develop a vaccine as soon as possible. We are more likely to have a supervirus created from nature itself than one from a lab, for example, coronavirus. Despite these very alarming risks, it is important to keep in mind that these risks are only hypothetical and can all be prevented and/or managed. Here are the benefits. Germline editing has many benefits, both proven and unproven. CRISPR-Cas9 has the potential to literally remove hereditary disease from our gene pool, alter our future genetics to increase viral immunity, and even remove defects from children to improve their lives. Martina Baumann wrote in her book addressing the ethical issues surrounding CRISPR-Cas9 that Miller thinks that CRISPR-Cas9 could conceivably eradicate sickle cell disease, a monstrous genetic disorder, meaning that any ban on human germline therapy would be unethical. As scientists like Miller stated, surely it is unethical to dismiss the possibility of saving lives from these monstrous diseases such as sickle cell anemia and more. As you can see here in the graphic, sickle cell anemia causes about 114,800 deaths per year, which is about a third of the St. Louis population. Also, each year, about 6,000 babies are born with Down syndrome, who are given a very, very hard life, and this technology would be sure to help that. Arinzi E. coli states, the technique has been used to customize modifications in several viruses with the aim of generating recombinant viruses, mutants, inhibition of virus replication, excision of provirus genes, or mutations in host cell receptors to prevent virus infection. More specifically, they have found success in altering many viruses. Within this article are several dangerous viruses such as Zika virus, Ebola virus, which have wreaked havoc in third world countries. This technology can and should be used to aid in the treatment and/or in the development of vaccines for viruses of current and those of the future. As you can see, it also can help in human immunodeficiency virus, which will improve the actual viral immunity of our population. Now that you know both the potential benefits and risks of germline editing, you can draw your own opinion on the topic free of bias. I hope the audience has been enlightened on CRISPR-Cas9 and may come to think of it as an ethical tool of the future that saves lives rather than a scary weapon that takes lives. Today I have mentioned a future that may have designer babies, eugenics, and man-made bioweapons, but I have also mentioned one in which hereditary diseases no longer cut lives short, the disabled could have a more equal opportunity, and finally one in which viral immunity of the entire population could and would improve. After all, this technology will change the future. We must decide whether it changes our future. And here are my references. And that is my presentation. Have a good day.